Alright, 2012 AMC, this is problem 10 from the AMC12B, and it says, what is the area of the polygon whose vertices are the points of intersection of the curves x squared plus y squared equals 25, and x minus 4 quantity squared plus 9y squared is 81. And so we have a circle centered at 0, 0 with radius 5. We have an ellipse centered at 4, 0 with semi-major axis of 3 and semi-minor axis of 9. So that graphically, that's not going to help me too much. But whenever I'm looking for the points of intersection, I can get those by solving a system of equations. So I have x squared plus y squared equals 25. That's my first equation. And I'm going to rewrite the second one by expanding out the x minus 4. So this equation becomes x squared minus 8x plus 16 plus 9y squared equals 81. I'm going to move the 16 to the right-hand side by subtracting it from both sides to give me a 65 over there. Okay, so we will get x squared minus 8x plus 9y squared is equal to, and I double check, yes, 65. Okay, and now by solving this, I'll get my answers. And I have squared, so I will not forget plus or minuses or anything like that. And what we see first is x's, can't really get them all to cancel, but the y's I can. And if I were to cancel out the y's, I'll be left with a quadratic function in the x's. So to get those to cancel, I'll multiply the top by -9, which means that this becomes -9x squared minus 9y squared equals -9 times 25 is -225. I'll bring over this blue equation as is and get x squared minus 8x plus 9y squared is equal to 65. And from that, the y squareds will cancel, and I will see that I'm left with -8x squared minus 8x is equal to -225 plus 65 should give me -160. And wonderfully, a common factor of all three of these terms is -8, so I'll divide through by -8 and get x squared plus x is equal to 20. And I'll solve this equation. It's going to be solved by factoring, so let's move the 20 over by subtracting. X squared plus x minus 20 equals 0. This factors as x plus 5, x minus 4. So x is equal to -5 or +4. And then I'll bring these back into one of these equations. I'm going to use the top one, it's a little easier, and find my possible y values. So if I bring it back in, so x equal to -5 will imply that -5 squared plus y squared is equal to 25. -5 squared is 25. So this means that y squared will equal 0. And so will y. So one of our points is the point 50. And I can check that in this other equation right here, 25. Let's see. So I put it in here, 25, sorry, -50. 25 plus 40 is 65, much better. Okay, the other equation, if I put the 4 into this first one, so I'll give you a big old mess. So x equals 4 will imply that 4 squared plus y squared equals 25. 4 squared is 16. Subtract 16, y squared is 9. And y is then plus or minus the square root of 9, which is 3. I didn't need a plus or minus here because 0 is 0. So the other 2 points are 4, 3, and 4, negative 3. I have 3 points. It'll form a triangle. I'll draw a quick sketch so we can see the triangle. I'm not going to draw the ellipse in the circle, but my first point is out here at negative 5, 0. My next 2 points are 4, 3, and 4, negative 3, over here and here. And this triangle, the base here, I'm going to use that as the base, is going to measure from 3 to negative 3, is going to measure 6. The height, let me draw the triangle. The height here goes from negative 5 up to 4 is 9, so the area will equal 1/2 6 times 9, which is 27, and my answer is B.